Welcome to William's Guide to Mathematics. We are here to talk about lesson 4 on the topic latitude and longitude, an important topic when it comes to mathematics. Let us take a look at lesson 4. In lesson 4, we are talking about how to identify problems involving distance along parallel of latitude. And then we will now look at how to solve problems involving distance along parallel of latitude. Let us start this way. Let us get the key points in identifying problems on distance along parallel of latitude. The first thing we need is we need to determine or know that the latitude will be the same. The latitude must be the same when having problems involving distance along parallel of latitude. Then once we have that, we still use the formula for distance along parallel of longitude, which is length over r, theta over 360 times 2 pi r, but we add cos alpha. Remember, for that of distance along parallel of latitude, or simply put, when we have a common latitude, we use an extra cos alpha, meaning the formula is theta over 360 times 2 pi r cos alpha. Again, theta is angular distance or angular difference, r is the radius of the earth, which we've taken to be 6,400, and alpha, which I'm introducing now, to be the common latitude. So we don't just discard the common latitude. It is relevant as far as an appellation is concerned, and we take that to be alpha. You can see it in the formula. Now we have example 1. In our example 1, we have 2 points. Let me go straight to representing these 2 points on the globe. Our globe with a circle. Let me start with the latitude, which is the equator, the blue dotted line, and the longitude, which is the red dotted line, which is the Greenwich meridian. Now, in our question, we have 20 degree north. The first point is 20 degree north and 30 degrees east. 20 degree north, that is northward of the equator. So that means I am taking the latitude, the blue line, northward of the equator, and then 30 degrees east, that is east to the Greenwich meridian, that is a line of longitude. So I will also draw that. The 2 points, they meet at this point. Let me call this point the point of intersection of these two, the latitude and the longitude. Let me call that point K. Now, another one, we have 20 degree north and 40 degrees west. Already in my diagram, I have the 20 degree north. I no need to represent that a second time. And that is also giving us an indication that what is common to the two of them is the 20 degree north, which is a line of latitude. Okay, we're coming to that. Now, we also have 40 degrees west. I need to represent that because it is not yet on the diagram. The 40 degrees west is represented in red. It is relative to the Greenwich meridian, so red. So it's on the west and it's labeled 40 degrees west. Now, like I said, we have our latitude to be common, 20 degree north. We can see that. But let me label the other one. I label the first one K. So let me label this one L. So I have my point L. Now, having my point L, I want to get the distance between K and L. They both have a common latitude of 20 degrees north. So how do we get the angular distance? That is the next thing we should be asking ourselves. The angular distance is theta, and theta, we get theta from the difference in the longitude. The longitude of the first one is 30 degrees east, the other one is 40 degrees west. We have different position, east and west. Remember, we said we add when we have different position. So 30 plus 40 will help us to get our theta 70. We are adding because they are east and west. Now, coming to our formula, theta over 360 times 2 pi r. I'm adding cos alpha because I'm dealing with the question on common latitude. Our theta, we've just gotten that to be 70. 70 over 360 times 2. Pi is 22 over 7, and our r is 6,400. we are using our cos alpha. So cos alpha is the common latitude, and that is 20. So if I multiply everything and divide by 360 and 7, which happen to be at the denominator, I will get 7,350 kilometers. The ship starts from the position 40 degrees south, 30 degrees west, sails due west, but we're not given the exact position, though they gave us the distance as 1,850 kilometers. Now, no problem, we don't have the new position, but let us get all this information represented on the globe. And we start by drawing our circle representing the globe. Then we introduce the special line of latitude and longitude. Let's start with latitude, the equator, the dotted blue line. Then the longitude, which is the Greenwich meridian, the dotted red line running from the north to the south. Now, having that, let us now put other position that is given in the question. We have 40 degrees south. 40 degrees south is below the equator. South is below the equator. So let's place that. It's a line of latitude. So I will also use the blue line just for clarity. You can use your pencil to draw everything. You don't have to use a color code to draw anything. This is just for clarity. So the blue line is 40 degrees south. While for the longitude, we have 30 degrees west. Of course, it's longitude because it is west of the meridian, which happen to be a special line of longitude. So the meeting point is the position of where the ship starts its journey from. So let me just call that position. Let me call that position M. Having done that, we're told that the ship sailed due west. Now, if the ship is sailing due west, west goes with either west or east. So it has no effect on the south, 40 degrees south, meaning our 40 degrees south remains the same. And in the diagram, it is obvious that the 40 degrees south represents the line of latitude, meaning we have a common latitude. So we are using our formula for distance along parallel of latitude. Now, we are given the distance already, so that means what we need to do now is to get the angular distance. Okay, let us go. We have our formula. Distance is equal to theta over 360 times 2 by r cos alpha. I'm adding cos alpha because the question involved distance along parallel of latitude. Now in the question, my distance is 1,850, so that is equal to, we don't know theta, let's put it there, over 360, our times 2, which is still 2, pi, we know that to be 22 over 7, times r, radius of the earth, 6,400, times cos alpha. We expect that the latitude will be the same, so that is cos 40. So multiplying everything we have at the denominator of the right hand side, we have 215,718.12. 215,718.12 with our theta, which we don't know, and all divided by 2520. That is the value from the denominator. If you divide the numerator and denominator, we get 85.6 with theta. So meaning my theta can be 1850 divided by 85.6, and that is 21.6 to be exact, and I can approximate that to be 22 degrees. So if the ship is sailing westward, and initially it is also on the west, that means it moves further to the western side, away from the Greenwich meridian. It is sailing next to, you can see the new diagram, it is moving to the west, to the western side, away from the meridian again, not towards the meridian. That means I will get a value that is more than 30. So that will be 30 plus our angular difference, 22, and that gives us 52. In trying to explain this example, let me start by drawing a globe to represent the earth. It's the circle, you can see it. Then we draw our special latitude and longitude. Latitude is the equator, the dotted blue, and longitude now the Greenwich meridian, the dotted red. Now, having done that, let us take the positions. We have 20 degrees south, that is just below the equator. It is a line of latitude, so I have my 20 degrees south labeled. Now, I do that of the 15 degrees, which will complement the position. 15 degrees east, that is on the right side of the Greenwich meridian, so that is a line of longitude. Now, these two meet at a point. Let me call them U. They meet at the point U. You can see it is there, U. Now, we have another point, 20 degrees south and 23 degrees east. I have 20 degrees south on the globe already. That is a line of latitude. So I will keep that aside. That is to tell us that we have a common latitude. But we come into that. Let us go to 23 degrees east. That is 23 degrees east. Still on the eastern part, just like the first one, 15 degrees east, 23 degrees east. Good. Now we place it there, we label it. It's also in red because it is a line of longitude. Now that we have this, remember I said we have a common latitude of 20 degrees south. So we are particular about the 20 now in our calculation. Okay, now we have a common latitude of 20 degrees south. Okay, before we use the formula in full, let's talk about our theta. How do we get our theta? Remember, we have 23 degrees east. We also have 15 degrees east. They have the same position. In our knowledge of angular distance or angular difference, we subtract for same position. 23 minus 15, that is 8. I'm subtracting because I'm having east and east, that is same position. Now let's go with the formula. Distance will be theta over 360 times 2 pi r cos alpha. I'm using cos alpha because we are dealing with parallel of latitude. Simply put, common latitude. Theta, we've just gotten that. That is 8. We have 360 in the question. 2 remains 2. Pi is 22 over 7. R, as we've been discussing, is 6,400. Then the cos 20. The 20 is the common latitude. If you multiply all this together and divide by 360 and divide by 7, you will get 840.06 kilometers. Now, the question is asking for the time, but we are given the speed. Remember a triangle that I discussed in lesson 3. Let me explain that triangle again. I told you we can put the relationship distance, speed, and time inside a triangle. D for distance, S for speed, and T for time. Of course, 1 will be up and 2 will be down because of the way the triangle is. Now, I told you then that you should arrange them alphabetically. So D comes up, S, and then T. Distance is up, speed is down, meaning time is distance over speed. Good. If time is distance over speed, and we've gotten our distance to be 840.06, our speed given in the question is 22.7 kilometers per hour. If I divide these two, I'll get approximately 37 hours. So it means the ship actually sailed from the point U to the point V for 37 hours. Now we have example 4, which will happen to be the last example for this lesson. Now this example will also tell us that we need either common longitude or common latitude. In this example, we have 3 points, just like point A to B and then to C. Let's start with the first part of the example, which is relating points A and B. We are asked to get the time. Okay, now for point A, we have 53 degrees north and long 15 degrees east. Let me just represent that on the globe straight. Now, we start with our circle. We draw the special latitude and longitude. Start with the latitude, the blue dotted line. That's the equator. Then we take the special longitude, that is the Greenwich meridian, which is the red dotted line. Now, having done that, let's go for point A now. 53 53 degree north. That is the northern part of the equator, 53. You can see that. Okay, that's the blue line labeled. Now we also have the longitude, which is 15 degrees east of the Greenwich meridian in red. So let me locate that point, the meeting point. You can see it, and the meeting point is now labeled as A. Good. Now let's take the other one also, that of B. Last 53 degree north. I already have it. I need not represent that again. Okay, let's take the longitude. The longitude is long 35 degrees west. So that is not on the diagram. So let me do 35 degrees west. That is on the west of the Greenwich meridian. That is on the left side, the left of the Greenwich meridian. So I have 35 degrees west already. Good. Now let us get the distance between these 2 points. You can see the angle in the diagram indicating the angular difference. To get the distance, we start by getting the angular difference. It's established already that our latitude is common. So we have a common latitude of 53 degree north. Let us now proceed with the longitude. We have 15 degrees east and we have 35 degrees west. Different position. Remember, for different position we add. So our theta will be 15 plus 35. That is 50, because we are dealing with east and west. So distance now. Which formula are we using? Is it the one for parallel latitude or parallel longitude? In this case, it is parallel latitude. Remember, we said we have a common latitude, that is the same latitude of 53 degree north. So we use the formula distance equals theta over 360 times 2 pi r cos alpha. I'm adding cos alpha because of the common latitude. So my distance AB will be equal to 50 over 360 times 2 times 22 over 7, which is pi, times 6,400, which is r, then cos 53. If I multiply all that and divide with the denominator, I'll get 3564.27 kilometers. 3564.27 kilometers. The question is asking me for the time. Remember, from this triangle we've been talking about, time is distance over speed. We've just gotten our distance as 3564.27, while the speed according to the question is 400. So if I divide 3564.27 by 400, I'm getting 8.9 hours, which is approximately 9 hours. So the time from A to B, the first part of the question, is 9 hours. The second part of the question is relating B to C. I already have B on the globe while drawing for the relationship of A and B. So all I need to do is just add the position for C. My C is 35 degrees north. That is a line of latitude, blue line. You can see it there. While my longitude for C is 35 degrees west. That will also be added. If you look at this now, relating B and C, we have a common longitude. Don't forget, in the question we're given the time as 6 hours. Okay, now that we have a common longitude, okay, let us take a look at what to do. Of course, since it's a common longitude, we are using the distance along the parallel of longitude. The formula is distance is equal to theta over 360 times 2 pi r. Don't tell me you want to add cos alpha. Cos alpha is for parallel of latitude. So I just stick with theta over 360 times 2 pi r. I stop there. Now let me put my values. My distance for BC will be equal to my theta. Now let me go back to getting theta, angular difference. I need to do that before I can apply this formula. In the question we have 53 degrees north for B, and we have 35 degrees north for C. You can see it on the globe. We have the same position, we need to subtract. In the diagram I have 53 north for B, 35 north for C. If I subtract 53 and 35, because they are both north, same position, I will have 53 minus 35 giving me 18. Now putting all this inside the formula, we have theta is 18 over 360 times 2 times 22/7, which is pi, times r 6400. So if I multiply all that, I'm getting 2011.43, which is approximately 2011 kilometers. The last part of this example, we have to get the average speed. Average speed is total distance over time taken. Now, the distance from A to B in the question, 3564.27, for distance of B to C is 2011.43. We add both together and divide by the time for A to B, which is 9 hours, which we calculated earlier, and the time for B to C, which is given in the question, 6 hours. So adding the numerator, which is distance, we have that. Adding the denominator, we also have that. Dividing, we are able to get our average speed as 371.71 km per hour, approximately 372 km per hour.